Alright guys, Mr. O here doing some review for the Algebra Equations and Inequalities test. So let's just jump right in. We're going to solve a couple of equations. And remember, of course, that I boil it down to three steps. One, can you simplify? So do you see any distributive property or combining like terms on the same side? And the answer to that is no. Step two, do you see any combining like terms on this, I'm sorry, not combining like terms, do you see a variable on the same side or on different sides? The answer is no, we only see the one variable. So finally, inverse operations, and we do it in reverse order of the order of operations. So this minus 3 is hanging out by itself, so we have to do the opposite, which is plus 3 would be the inverse operation. And after we add 3 to both sides, we're left with x over 4 equals 2. And the way we undo this divide by 4 is we times by 4. Giving us a final answer of x equals 8. So let's get into a little more heavily involved problem, a little more complex. So step 1, can I simplify? Yes, because I see those parentheses, which means I can do distributive property. So 2 times 5k would be 10k. 2 times a negative 6 would be a negative 12. And then we did nothing to the rest of those things, so we leave those terms alone. Just bring them down. Still looking at that same step 1, can I simplify? So do I see any combining like terms on the same side? And the answer to that is yes. The negative 4k and the 10k would combine to 6k. And then everything else just stays the same because we didn't do anything to it. Do we see a variable on both sides? Yes, we do. And here I usually suggest getting rid of or eliminating the smallest one. So instead of minus 3k, let's add 3k. That way I have a positive k coefficient. So 9k minus 12 is negative 39. So we have to inverse operation. So honestly, we've come back to the same point where we were with example 1. We've just got this constant term, so we have to undo it. So instead of minus, we add. So 9k equals negative 27. So now to get rid of the 9, we have to divide because we were multiplying. And once we've divided by 9 on both sides, k equals negative 3. Alright, so at this point we're going to take some word problems and turn them into equations so that we can solve. So in example 3 we've got that I'm 500, how old am I if 500 reduced by 3 times my age is 206? So the value we started with was 500, and then I'm reducing, which would be subtract, 3 times my age, so 3, and since age is unknown, age is your variable, 3a, equals, and then we have 206 at the end. So right here, just like the previous problems, can't simplify, don't have a variable on both sides, so as a result, we're going to cancel out this constant term that's hanging out by itself. So instead of a positive 500, we're going to minus 500. And of course, we do that to both sides. So negative 3a. And don't forget about the sign. The sign's got to stay with that 3. Equals negative 294. And the next step, we got to cancel out the negative 3. Since it's being multiplied, we divide. Dividing on both sides. So A ends up being 98 years old. Alright, so now we're going to talk about a town's population. And I want you to notice we have first the 14,000 person town increasing by 160 every year. So that's going to be one portion of the equation. And then we've got 24,000 decreasing by 200 every year. So that's going to be our second half of the equation, because we have two separate towns, two sides of the equation. So starting off, we have 14,000. And if it's increasing, we're going to add 160. Now the 160 is contingent upon that it's every year, so we need to have the variable y equals. So then the second city starts out at 24,000. And this one is decreasing, minus 200. And that is happening every year. So, can we simplify? No distributive property, no like terms on the same side. So next step is, do we see a variable on both sides? Yes. And since this is a positive 160 versus this being a negative 200, let's do the opposite and keep that coefficient whole, or at least positive. So we're going to add 200y to both sides. So 14,000, since we didn't do anything to 14,000, plus 360y equals 24,000. And next, we've got to do our inverse operation, so we're going to subtract off the constant term. So minus 14,000 from each side. Resulting in 360y equaling 10,000. And finally, we need to cancel out the 360. So since it's multiplied, we're going to divide, and you divide by 360. Now this problem doesn't come out as nice as we would want it to, because y ends up equaling 27.78 years. Alright, and the final three examples for this video, because I'm going to do equations in one video and inequalities in the other. Let's take out these proportions. So we have to multiply by both denominators. So multiply by x and 9, because we're dividing by both of them, so we're just doing the inverse operations. So we're left with 6 times x on the left-hand side equals 10 times 9 on the right-hand side, which would give me 90. And inverse operation, how do we get rid of the 6? Well, since it's multiplied, we divide. X ends up equaling 15. Alright, so in 6 and 7, these are both proportion problems. You just have to identify what we're talking about. So in the first, in example 6, we're talking about gallons of gas versus how many miles we can travel. So the first thing we see is that we can go 10 gallons, we're able to travel 180 miles. And then we want to know how many gallons, so we don't know. So some arbitrary letter variable. And we want to know how many gallons it'll take to go 450 miles. So just like the standard problem above, multiply by both denominators. So after we've canceled those out, 450 times 10 is 4,500, which equals 180 G. And to simplify, we need to divide by 180 on both sides. Resulting in G equaling 25 gallons of gas used. Alright, so for the last problem, I'm not gonna do all the work on it, but I am gonna get it set up. So we've got the baseball pitcher, and we're talking about the number of games that he has won versus the games that he pitched. So we've got 1 versus total. And when we're dealing with this, we're going to have a percentage. Now, percent just means out of 100. So 80% is 80 out of 100. If he were to pitch 100 games, he would win 80 of them. Equals. Now, if he pitched 35 games, so that's a total, they want to know how many games he would win. So right there, go through, do the same process as example 5, example 6, and I think you end up coming out to 28 games that he ended up winning. So double check that and make sure. But anyway, I'll come back in just a little bit and I will have part 2 with the inequalities and other things.